So just have a discussion and go through of this. And so we have been talking about quantum cryptography and the problems that a quantum computer can bring in, like breaking the current classical systems, and how quantum cryptography is a solution, like how it can save our systems from being attacked and all those. But when we have when we are looking into all this, we have some loopholes or issues with these systems as well. So Lee, see, if that is the most secure option and it is very much implementable, why not everybody is implementing it right now? So we have to go a long way ahead in this path. Only then these unconditional security we are talking about can be implemented. So the when we have come across, we have been learning about things, many issues and many areas that could be improved were analyzed. This is not the complete list. There are many in this, but those things that came across our minds are being listed out. So the first thing that we all know, that when we are talking about BB84 protocol or whatever, currently we cannot move into a system that is completely a quantum based, and also there is a dependence on the authentication channel which is very much unavoidable as of now. So when we are depending on this authentication channel, a man in the middle attack, or even see, we know we have light pulses, or light, we are making use of light as the source. So if we simply introduce a large or heavy pulse of light into the system, what could happen is the communication could be broken. Or if we introduce large number of noise, what could happen is, like, let's say they wanted 100 bits at the end of the QKD protocol. We know we will discard so many photons, isn't it, throughout the protocol. What could happen is the sender and the receiver could end up discarding large number of photons. So end result could be that they will not be able to proceed with the communication itself. So what I'm trying to tell is, like, if we can actually interfere and play around with the complete system without even interfering it and reading it. So externally I could simply introduce so much noise, I could simply introduce a large pulse of light into the system, and I can make the system infeasible to have a key distribution. So that is one major challenge we have right now. So they are going with a lot of solutions, like which is noise resistant, which is there's with specific channels created for it. We are transferring the data at a specific time. We have satellite based solutions. So that is one area. Then we have the hardware dependencies as of now. So if we are talking about photon sources and all these sources have some sort of hardware mechanism or method of working. So these dependencies are not foolproof. I mean, these methods are not foolproof. So if those dependencies, or the way that those hardware devices works, if that could be misused for an attack. For example, if we have different ways to use actual photon sources and faint pulses of sources as well. So if we use actual photon sources, there is chance that many of them have some probabilities of multi photons emission. So this property can be misused by an attacker, by making use of photon number splitting, etc., and even read the photons without even being detectable in the system. Then if we use faint pulse sources, there could be loss in the line, errors, and so many other problems could be there. So if we move deeper into that, hardware based dependencies are more. So we have to have efficient photon sources, or even efficient methods to read this faint pulses that is going on inside that. Then we have measurements. So we have different protocols applying different ways of measurements and all. So the same type of measurements can be done in each devices. We have different devices to do those measurements. So the best way to do such a sort of measurement, which is the type of measurement or these protocol that could be applied in my application, the error that it can accept, and the error that could come in, the distance I have to go through to achieve this, where my sender and the receiver is. Now if I need to store it for some time, again the introduction of the classical systems comes in. As we know, our quantum based storage is still a long way ahead. So where am I going to store it? Now if I'm going to store it for a long time in a classical storage, like how secure it is, like if that classical storage is going to be visible to an attacker, how I can save that. Now another important thing is the adoption. See, we had spent a lot of effort and lot of time in like developing the systems that we have today. If we go ahead and say that now change everything, change the hardware, change the protocols, change everything around it, it's not so feasible. So how we can like adopt and bring in the security systems without disturbing the existing hardware and the security systems that we have implemented today, that analysis is very important. Like without changing the stack that we have built up, the security systems and the levels that we have built up today, we need to introduce something which extends the security, which can be secure, but at the same time provides the enough amount of, or the more amount of the required amount of security that we need. So adoption is one major thing that every organization is confused and talking about a lot, like what amount of adoption, what level of adoption should we take in. So when we talk about the research areas, there are many. So as I've told, these are the main things that we have listed out. We have to have relay nodes. So again, when we talk about hardware dependency, if we have a long distance communication, we have some relay nodes. These nodes are supposed to be trusted. So how we can trust them, how we can ensure that these trust of these nodes can be maintained, then earlier storage, how we can have machine independent schemes, how we can achieve a long distance communication, then then how we can have I believe somebody is writing on something, so that my screen is going down and down. Is someone using the screen right now? Any of us?
Uh, yeah, I think Vaibhav was using. Huh. Guys, don't close.
No,
Just
I'm
wait.
not using right now.
Archit. Okay. Whoever was using, don't use that.
Sorry, I could have used a separate window, but I suddenly started sharing from here itself. Okay, so whatever research areas we could look into is one major area is the quantum internet itself. Why? Because if we have a successful internet or a network, quantum network that is established, then many of the problems that we are talking about could be, but again that is a long way ahead. We have to have a complete structure looking. There are many prestigious organization and communities that is looking into it. So but still we have come across long way ahead, and these lists that you see here is the proof. So there are many direct companies we have which has started to provide products that is based on these systems that we have been discussed. We have direct solutions which we can plug and play, like you need not even disturb the existing system. And these are actually some of the companies that we came across. This list is not at all complete. You can have many more companies that is contributing. Again, here you can see a list of companies that is, and we have our Indian company Labs. It needs to be pointed out. Then we have companies who are actually contributing in the hardware sources. Like you can have a quantum source generator. You can actually, you need not even buy these devices. If you have a team in your organization, you can actually buy or assemble the complete system using the devices that is separately available. You can have quantum measurement devices or even photon sources. So based on that, you can build up your own devices. There are many companies that is actually competing in this area as well. Then like there are a lot of projects which was earlier pointed out, which was talking about quantum safe, making it quantum safe through post quantum cryptography as well. So many studies are being done in that area as well. Now again, if we talk about the research projects that is trying to explore this is like how to secure in post using post quantum cryptography, then again how to have a safe network communication through quantum communication network itself, then we how we can have repeaters. So when we talk about repeaters, it's not just the having a physical repeater there, it is about achieving the key distribution systems, having to be able to make it deliver the distribution for long distances as well, because that is very much important to have a communication which is long distance, like we need to have it delivered between countries, and also that is another major research. Now another important thing that we have to think is that we have been telling that quantum computing is coming in our current systems are in the under threat. That is the only angle we are looking it at. It is not like quantum computing is coming in, our classical encryption is under threat, then we have to have some solution. It can be either through quantum encryption or post quantum cryptography secure it. That is the only angle that we talk about usually, but there is another advantages that you can bring in through quantum computing. So we are trying to put it out here. There are different areas where current efficiency is not able to provide solutions. Like for example, you have a heavy log system or even intrusion detection systems and all, which could be actually made more efficient by the unique when we use quantum machine learning concepts included in it. So it can be used to enhance our security as well. So there is one angle where we can improve our security by making use of the quantum computing capabilities that we are building on. Next thing could be there are a lot of algorithms which were actually secure or which provided a good amount of security, which was not implemented because of the computational restrictions or something like that, which was discarded in the past because of various reasons. There could be so many algorithms waiting to be rediscovered and be applied into our current computational powers or these systems that we have today. So many things could be explored. We can make use of quantum computing capability to understand how well the systems could sustain in a world, at least for a time. So we can make use of strength analysis, and we can extend the level of strength analysis of the various systems. Like we assume they are powerful, they could be broken, or so we can actually test on them and understand how it works and everything. There are a lot of other possibilities how we can make use of the quantum capabilities to enhance the security as well. So that area of research also needs to be explored, like how we can make use of the quantum computing capabilities to enhance our security as well. So that is sort of a summary what we have gone through. This list is not at all complete. So there is so many things going on in this, like very much interesting and very much like we can say what search results you get in the initial Google search. That those are the things that could be what you are seeing in front of you. But it is very interesting. See here, you can see 5OTX and all. They are this is a patent waiting technology here. They are putting it out that they can achieve QKD distributions across any distance. So that is all breakthroughs actually into this technology. We have to wait and see where it is taking us and where we will be in the coming future. Okay, that's all about what I have to tell. Thank you. Is there
All right. Lovely. Guys, any questions? Acha, Mahima, can you quickly talk about tomorrow's session, the continuous variable based QKD?
Okay, tomorrow we will have continuous variable QKD system discussion. When we talk about QKD systems, there are basically like different ways you can implement things, like having the quantum key distribution achieved. So one is discrete and other is continuous. So both system has its own pros and cons and development independencies and dependencies and all. So continuous variable QKD is something where so many researchers are looking into right now, especially because of the long distance achievement that we can achieve through those systems. And like that is one major area where a lot of studies are being. So our team we will be discussing on that continuous variable QKD in two sessions. So tomorrow we'll have one of that, and we will look through all the different methods that are being applied, different measurement schemes that we use, and some of the protocols that we are using in that. And Vaibhav, maybe he can add on some points as well. Vaibhav, you want to add on something about that?
Yeah, so tomorrow, basically, whatever I said, we will discuss. Basically, we will introduce you to continuous variable systems, which is not known, which is still not that mainstream yet, like discrete variables are. So, yeah, so tomorrow will be a good session if you want to learn.
All right, cool. Okay, so guys, also next week we'll have a lot more things to talk about in terms of use cases, because we would have finished our discussion with Dr. Anandita as well. So we'll keep you guys posted on use case developments as well. Okay. And tomorrow 4 to 6 is a peer learning series. So every team, quantum hardware, machine learning, and cryptography team will be presenting tomorrow. Right. See you guys tomorrow. Thank you.